So what insert helper does, it splits the list into two different parts. So when insertion sort is calling insert helper, it splits the list into the first thing and the rest of the list. Now insert helper assumes that there is a sorted part and an unsorted part. Now we know that when the unsorted part becomes empty, then we're done. We'll just return the empty list and then concatenate the rest onto it. So unsorted is empty. We have completed our recursion, reach our base case. So what will we return?
Sorted list. Sorry, sorted.
Right. Else
Else you're gonna return the first item.
well, you're
You're gonna
going to
check.
then be inserting
great.
something into the unsorted list.
If it's greater
You know,
than.
check if the first one is greater than.
Greater than.
No, we're not doing any checking if it's greater than at this point in time.
You're gonna insert the first element or
The items sorted list. So the first thing from the unsorted list will end up going into the sorted list. And then we're going to be calling insert helper to make sure the process continues. Now, insert helper takes two lists. So the first part of the list is the sorted list. So we call insert helper again. We will be increasing the size of the sorted list by 1 through adding the first thing in the unsorted list. So we're going to be calling insert helper on the new sorted list, which is the result of inserting one thing into the sorted list. So insert 1 car unsorted into sorted. So that's a sorted list growing by 1 item. And then insert helper takes 2 elements or 2 lists, 1 sorted, 1 unsorted. So the sorted list will be growing by 1 item. So therefore unsorted list would have 1 more thing cut off. So the second argument insert helper would be
sorted.
critter of unsorted.
Sorry.
The rest of it.
The rest of the unsorted
Okay.
list. Alright, now we're asked to explain why the worst case order of growth for the insertion sort is theta n squared. Why could that be? Let me help you. Now we know that we have some basic ups here. If we could actually do the analysis, but the time is running short, so I'm just going to do a qualitative thing. We see some basic ups in this procedure. Alright, this is insertion sort. Insertion sort is pretty much a reverse, can be a theta process, because you're going to be looking through each thing and then flipping the list. Insert helper is really what does all the work. Everything else is a basic up. Now, if we get the analysis of insert helper, then we know what the order of growth of the insertion sort is. Now in insert helper, we have some basic ups, and then we have a call to insert 1, and then we have a recursive call to insert helper, which cuts down the input size of the data it's working on by 1 unit each time. So insert helper is basically linear by itself, but it does refer to this function here.
But then,
Which-
sir,
Mhm.
it says descending. Isn't that what it is, something?
Descending,
Or largest to smallest.
I'm not sure how descending comes in.
Because it has the word reverse.
Yeah,
Reverse.
it's been reversed.
Oh, they-
Reverse.
Yeah, once you copy the things across, they may end up in the wrong order in scheme. So you can call reverse if you want, but it's a theta in, this is a theta in process.
Okay.
So, but that won't really affect our analysis. If we're doing the full analysis, we would have needed to get the order of growth of this. But it's reasonable to, it's easy to see why we can reverse a list by maybe copying the list. And for n items in the list, that will take n steps. So reverse with that theta in process. Now, in analyzing this part, we would need to know the order of growth of insert 1. So we could determine that by looking over here, by working out that insert 1 steps through the list, and each time it reduces the input size by 1. So it's a linear function. So that's going to be a theta in process. So insert 1 is theta in, and it's called up to n times. So this is going to be a theta n squared process. So short of going through the whole step of doing the full algorithm analysis, we can use that qualitative and explain that time complexity. Now, one nice property of the insertion sort is that it's an in-place sort, meaning that we don't need to make another copy of the data as we sort it. We sort it in place in the array, or in whatever data structure we have. And if we're sorting a lot of data where making another copy of the data is not an option, then we can see how valuable that can be. There are sorts that are not in-place sorts. Alright, I think we did the bubble sort one in the tutorial. I didn't see much problems with that. And we don't have much code, which I know you have issues with. Where we have code is in the next tutorial. Alright, we can quickly do the bubble sort here.